Welcome to Chapter 7, which is on arrays and lists, and this is Part 1. First, we're going to talk quickly about our chapter goals. Number 1 is to collect elements using arrays and array lists, to use the enhanced for loop for traversing arrays and array lists, to learn some common algorithms for processing with arrays, to learn to work with two-dimensional arrays, and to understand the concepts of regression testing. So, an array collects a sequence of values of the same type. If you create an array that can hold 10 values of the type double, you do it by saying new double 10, which is the size. The number of elements is called the length of the array, and the new operator constructs the array just like any other object. The type of an array variable is the type of the element to be stored, followed by a bracket indicating the size. Now, you may often see this bracket empty, which means the size is indeterminate at first. To declare an array of type double, for example, you'd say double bracket bracket values, and it's currently an uninitialized array, so don't do anything with it. To initialize it, you can say double bracket bracket values equals new double 10, and the advantage of doing it that way is you can chain things as you need to. You can assign a different array as long as it matches the type specifications. By default, each element of the array is set to 0. You can specify the initial values of the array by listing them out, and it will count for you the number you actually need. To access a value in the array, specify which slot you want to use using the index operator, which is a right bracket followed by a left bracket followed by a right bracket. All the indexes begin at 0. The slot number is called an index. Each slot contains an element. They are accessed by an integer index I using the notation array sub I, and it can be used pretty much where any variable can be used. So here's an example. We have value, declare the array variable, initialize it to an array, and now access an array element. So if we wanted to get to number 5, it would be values bracket or values index 4 will give us the 5th element of the array because we start from 0. So the syntax is simply this: type of the array variable. You also have the brackets, the name of the array variable, and new, the element type again, and length. Or instead of the length and the new, you can actually have a list of initial values. You access it by using the bracket and an index. The index must be greater than or equal to 0 and less than the length of the array, not less than or equal to. The elements of an array are numbered starting at 0. An index, if in this example, an array of 10, an index can be any integer rating from 0 to 9. The first element is value sub 0. The last element is value sub 9. An array index must be 0 and less than the size of the array. It's kind of like a mailbox that is identified by a box number. If you go outside of those bounds, you're going to get an error. So, for example, we have an array of 10, and we assign something to the 10th element. Well, that's outside of the bounds because it has to be less than the length. Length, by the way, the function to check the length is array.length, and we don't use any parentheses because it's a property of the array, not a method. So here's some examples of declaring arrays. Int brackets numbers equals new int 10 is an array of 10 integers, all elements initialized to 0. We could use a constant instead of a magic number here, which is a good practice. It doesn't have to be a constant. You can read in the variable from the console and use it. You can use initial values. You can also do this with string. However, you cannot mix types like everything else. An array reference specifies the location of an array. This is a little different than in C++, where it identifies the location of the first element. Copying the reference yields a second reference to the same array, just like with any other object. When you copy an array object variable into another variable, both variables refer to the same array. You can modify the array through either of these variables, something to be aware of and careful of. Arrays can occur as method arguments and return values. We can pass in an array, and we can return an array. Array length is the maximum number of elements. An array can be partially filled, though. You can have 100 elements and only fill in 50. So you usually will keep a companion variable along with it called current size, which will tell you how many you've actually used. But the compiler doesn't maintain that for you, that's up to you. So a loop to fill in an array, we read in a value while we can get more values and we have more room in the array. We add it to the current array and we increment our current size. At the end of the loop, current size is the actual numbers array and length would still be the maximum number of items in the array. So here's an explanation of the differences. Current size is the number actually used. The length is the total size of the array. We have this unused area. Don't forget to use the companion variable. The partially filled array, you need some way to remember how many are actually used. Think of it like a beaker. It's only partially full. Don't do this. Don't have an array of count numbers, an array of balances. Don't use parallel arrays. This will get screwed up. Instead, use an array of objects. See, for example, we have a bank account object. Here we would create an array of them and assign each field individually. So let's take a simple example. We're going to declare an array of primes, for example, the first 5 primes. And then what we're going to do is we're going to tamper it with it a little bit. We're going to write a loop that basically changes the last couple values in the array to the first couple values of the array. See, so basically here we go, and we run through and set the 4th and 5th values to the 1st and 2nd. And here's another example. We can take that array, run through it with another loop, add 1 to each prime, and this is what we get. Obviously, these are contrived examples, but they should give you a better idea of what arrays actually do. Now, let's declare another array, and we can put the integer 10 in the element of the array values with the lowest and highest index value. So we'll make value sub 0 equal to 10, and value sub 9 equal to 10, although a better way to do this would be values sub values.length minus 1, so you guarantee you don't have any overflow. We can declare arrays of strings. Let's take this example. Here's an array of strings going from 2 elements with the first one equals yes and the first one equals no. So we're not just limited to integers. So I'll take another example. Let's declare a class lottery and have a method getCombination which returns an array of integers. These are just some very simple examples, and using them we can hopefully come up with some great solutions.